Hi, class. This is just a short video on the week 3 discussion. And this is the revision, so make sure that you're not using the file under discussion. The file is in doc sharing. And so for week 3, we're looking at something called correlation, which is just a mathematical relationship between two quantitative variables. So you just are going to work with two um, sets of data values. You have both of them will be numeric. And again, uh, this is correlation, and it's specifically linear correlation. There's lots of different types of correlation, and we're only looking at how well that the points fall in a straight line. So if we were to graph the ordered pairs, just like in algebra, when you had an xy plane, uh, you had an x value and a y value. So each point had two numbers that were associated with it. So if you graph those ordered pairs in a linear function, you came up with a straight line. With linear correlation, you don't have all the points fall in a straight line fashion. So what we have to do then is decide, well, how close do they fit that line in a sense? And that's what we talk about. So we have a correlation coefficient, and it describes the strength of the relationship and whether the relationship is positive or negative. So you can have a strong positive linear correlation, you can have a strong negative linear correlation. And so again, we're just going to look at the direction of the points, like slope of a line in algebra. So, is the line going up, right, positive, or is it going down, negative correlation? And then the strength of the correlation, we're either going to say basically it's kind of weak, moderate, or strong. And those are just, there's no hard, fast rules. It's just, how people typically talk about the strength. Now, if we want to know exactly, then we will look at the correlation coefficient. The linear correlation coefficient will be a particular number that ranges between -1 and 1. So that R value, that sample correlation coefficient, so it shows strength and direction here. So if you're right around 0, that's weak. So a little bit above 0, a little bit below 0. So we consider those weak correlations anytime the ones around here. When you get out more into the middle, around 0.5 or -0.5, when you're around those are considered moderate correlations. And then when you get up close to either +1 or way on the other side here, if you're close to -1, those are considered strong. So you can have a strong negative correlation. You can also have a strong positive correlation. So we're just going to discuss that a little bit with some data. So you're going to go out and collect some data, build a table, compute the correlation coefficient, and then just kind of talk about whether you think it's positive or negative, and what that relationship is, strong, moderate, or weak, and what that may be saying about the variables that you chose. So remember, we're not trying to prove anything. You can never prove that one variable causes the other with linear correlation. So we're just trying to build some support. That's what statistics does. Now, so review the week 3 material. You got nothing to post right away. Just make sure you look through the materials on correlation, learn about it, and then you're going to come up with 2 quantitative variables. Do not use any of the variables that were used in any of this discussion examples in week 1 or 2, okay? So, or 3. You're to go and find, again, 2 variables related to your program of study. So whatever you're studying at Walden, whatever you're in, your program is, we're going to look into that area. You can search the internet, come up with variables very easily. Okay. If you can find data, great. If you have to kind of put some numbers in there, make sure you have at least 15 pairs of data in your data set. Okay. And don't include any extra columns of data other than the ones that you're going to talk about. A lot of students have a tendency to throw a bunch of different stuff into there, and that just gets confusing. It doesn't help the discussion, and the discussion is supposed to be something that you and your classmates, talk about in a very basic, way, and get some ideas, and kind of help each other learn about what these topics are. In this case, linear regression. So, for example, let's say that I would like to study the relationship between a person's weight and their systolic blood pressure. Again, so that's something that you're not going to talk about, weight and systolic blood pressure. It's two other quantitative variables, right? So let's say that we believe that a person's systolic pressure depends on their weight. So in other words, their weight influences, what their pressure is going to be. So that would leave then the systolic pressure, the dependent variable, and weight would be the independent variable. So you want to identify those in your study and your discussion. Okay. And then here's the table. I got 2 columns, and that's it. So we have 2 numeric sets of data values here, right? These are quantitative variables. Weight, systolic pressure. Here's my input, my independent values. Here's my output, right? My dependent values. So by day 3, you're going to have scatter plots, and they typically don't work well if you just try to put them in a discussion area. So if you open up a Word file, and you can copy paste those in very easily from StatDisk. Includes your data set, right? So you want to make sure you have your set of data values. You're going to have a scatter plot, and then look at the scatter plot and see what does it tell you visually. What are you seeing visually from those bunch of points? How well are they falling in a straight line? Are they going up? Are they going down? Are they kind of weak, moderate, strong, and so on? And discuss the strength of the correlation, right, too. And you're looking at the R value. Now, what are some other variables that would affect the math correlation? So you want to think about what else affects people's systolic pressure. Well, it's not just weight. Even if you had a strong correlation between weight and pressure, you know that people's pressure is not determined solely on weight. So you could talk about it and say, well, it could be hereditary. It could be the medication that they're taking is causing their pressure to be rising, or higher or lower or whatever. And so there's lots of other reasons. They could have under a lot of stress, right? They could have some kind of disease. So there's lots of other variables, right? It says, what are some other variables that would affect the relationship between the 2 variables? So you're going to write those down. And then describe a correlation study that you might conduct in your field of study, aside from the one that you just had come up with. You don't have to collect data on that one. You could just say, you were thinking about these things, and maybe are they related? And you might want to do a study on those. And then the rest of this is the same as the other ones. Okay, you're going to respond to at least 2 of your colleagues in 2 or more of these ways, and in return look at your responses, people that how responded to your study, and so on, and then hopefully that goes well. So let's take a look at. I'm going to take this data after I put it on my table. Okay, I'm going to take this data and copy it. And here I have StatDisk open, and I'm going to paste it in there. And then go back to my data again. and paste it into there. So I got my data in the stat disk, and let's go to data and box plot, scatter plot. There we go, scatter plot. And let me open this up a little bit. Okay, there we go. And so X is column 1, and then the Y value was column 2. So my independent, there's my weight, right? And there's my dependent, my plot. So see, and then we're going to look at this and see. And again, you can copy paste this. Here's your copy. You can do Control V into Word to get it to paste. But you'll see these are kind of scattered around. They're not in a line. So here's the line of best fit. If there was a perfect correlation between the two, they would all be right on that line. Well, they're not. There's some up here and down here, and it looks a little positive. It looks like they are going up, and they're kind of scattered. So I would expect a weak positive correlation here. That's what I would be, talking about this, because again, they're really scattered about, but they are going up some. And well, what's the value, right? If I want to talk more specifically about correlation, and regression, variable, X variables in 1, Y variables in 2. There's a lot of stuff here. You don't need to copy paste this into your discussion because you're not going to talk about any of this. So it just gets confusing. Correlation coefficient right here, right? You have a positive R equal 0.4. So it's kind of like what we said. It's positive correlation. And it's kind of weak. It's, yeah, you might want to say moderate, but I don't know. I guess there's somewhere around there. You could say either one. But that's not very high. I'd say moderate, I guess, is good enough. So that would be about it, right? That would be it. And then you could, discuss the other study that you would want, and so on. So hopefully this one will go well. I think you'll do fine. Again, if you have any questions or so on, just email me, and I'll be glad to help out.